quickly. I apologise for the fact that it's slightly over to one side and there's a big gap down the side. Don't worry about it because you should be able to read everything. So, my talk's about functional reactive iOS, and you might be put off by the fact it says iOS. Don't be, because what I'm going to talk about is actually fairly generic. It could also apply to iOS 10, so I imagine you're now equally put off, if not more so. It's also kind of applied to .NET. It applies to JavaScript, that's your bent. In fact, it could be anything. The talk probably should have been titled, Why You Should Consider Functional Reactive Programming, but it's a bit more long-winded and less kind of exciting, so it could have turned into Functional Reactive iOS. If you've ever seen a talk from me before, it always has to have a massive picture of my face in it. That's me. I want my real name on Twitter, shouldn't care. And my blog is I want my real.name. I'll have the slides and links to code and all that kind of stuff up on there at some point soon. If you've also seen, the other thing you'll notice if you've ever seen a talk from me is that I like to self-promote. There's a free book that I wrote called iOS 7 Day by Day, so that teaches you about things that you can do in iOS 7 for developers. There will be another one, kind of originally titled iOS 8 Day by Day. So you can get that for free on that URL. I work for a company called Shinobi Controls. 2 slides about them, very, very simple. We build native UI controls for iOS and Android for doing things like data visualization, for doing charting, for doing grids and that kind of thing. You can follow us, Shinobi Controls, on Twitter, and you can get free trials and stuff from shinobicontrols.com. If you've got any questions about that, come and ask me later or look them up. I'm not going to talk about that anymore. So, what is functional reactive programming? Because that's kind of what I want to talk about. What is functional reactive programming? Well, I'll break it down into 3 things. So, what is programming? So obviously, what is programming? I have no idea, so I looked it up on Wikipedia. That's what it told me. I think that's what you probably need to know. I'm kind of assuming you know what programming is. And if you don't know what it is, I'm not the person to ask to explain it to you. So functional, what do I mean by functional? I'm not a language expert, I'm not a language design expert. This is kind of word association. When I think of functional programming, I think of these kind of things. I think of something that's stateless. I think of things that are immutable, and I think of first-class functions. So what do I mean by this? By stateless, I mean it's all comprised of functions which, for which their output only depends on their input. They have no state inside them. There's nothing inside them that, if I give the same input to my function twice, I'll always get the same output twice. You're never mutating in the state, which is this kind of stateless thing. The first-class functions, but so none of these things aren't necessarily required to be functional, but first-class functions, these functions that you can pass around. So we're talking lambdas, we're talking closures, we're talking kind of function pointers, I guess you could. Yeah, so that's the kind of stuff that I'm talking about, and I think that'll become clearer what I mean when we go into it a little bit more. Reactive. What the hell does reactive mean? Well, reactive is talking a little bit about how the way you think of your program. It's when you start thinking of your program, your app, in terms of data flow. So, as opposed to deciding what's going to happen. And one of the best examples of this, I think, is spreadsheets, right? So if you're building a spreadsheet, you put a formula in a cell, and then that references loads of other cells. When those cells change, then the cell you put the formula in automatically updates. It reacts to what's changed. Rather than going and asking for data, you're registering your interest in data, and then eventually that'll arrive with you somehow. That's kind of reactive. It's all about reactive. So given those little definitions I've given you, then functional reactive programming is obvious, right? Well, I'd argue it probably isn't. I have no idea what it means given those things I've just told you. This is the kind of thing that we're talking about. We're talking about immutable events. So we've got events can be anything, and we'll look at the kind of stuff that can be later on. But they can be anything, and they're immutable, so you can't change them. You just have a stream of these events in some respects, coming from somewhere. Again, we don't care what. And then on top of that, you fit some kind of functional pipeline. So there's a pipeline of these functional methods that I talked about before. That then they don't mutate these events that come in, but they react to them in some way. And you end up with these reactive signals. And that's all a little bit abstract. And I think if you think of it as, it's like a socket, right? Or if you've done any Unix, Linux, command line stuff, you're doing functional reactive programming because there's lots and lots of little programs that do one thing, they do it very well, they don't have any state kind of associated with them, and you take the result of one thing, you then pipe it into the next thing, that does something, then you pipe it into something else, and then in the end you kind of cat it out or something like that, you cat it from beginning to end. You're making these, you've got this pipeline of things that each receive events. Now in that, if you're catting in Unix, then your events are a line of text. You get a line of text coming out of cat, you do something with it, with sed, you then, I don't know, you might grep that result of that and that kind of thing. So you end up with this pipeline of things. So I mean, that's a really kind of handy way, and that is functional reactive programming, give or take. Another really useful kind of definition of this, and I'll come back to it again later on, is that it's a standard interface for events. So whenever we're building software, we're always dealing with events. Now events can be anything, but there are always these event things happening. And what various libraries of functional reactive programming do is give you a standard interface. More SQL, quite what I mean by that. Now, one of the foundations, one of the core parts of functional reactive programming is this concept of a signal. There's loads of other stuff, but signals are the core of it, and in actual fact, are kind of the requirement. So I guess we have to look at what the hell signals are. A signal represents a stream of immutable events. That's kind of what it is. So, if you're imagining a signal is just an object that spits stuff out, spits out these events. That's all it does. That really is that simple. Now there are various different types of events that you can have. You can have a next event, so that's kind of, if you've got something, so if we go back to the analogy with the Unix command line, the next event would be, here's your next line of text that I've captured from the spot, here's the next one, here's the next one. So you get a sequence of next events coming out of this signal. Completed is kind of, you can get that, and that's saying, I've finished now, there's never going to be anything else coming out of my signal, that's it. So that will be the end of a file, right, in my cat analogy. And then error, so I've got to stop because something's gone wrong, so maybe the file gets deleted or something while you're recording. Maybe just some idea of what signals are. Now what can they actually model? We're going to start a little bit of a technical level, and then we're going to look at more kind of real world examples. So this here comes back to the thing I said about it's a standard interface for events. So this is particularly true in Cocoa, so Objective-C, iOS, OS 10. But you see this kind of pattern all over the place. And that is, so something like delegation, so if you've ever used the delegation pattern, then pretty much you are expecting to be called back given some kind of interface. Now those callbacks in your delegate are just events. You can map those as events. Same with some kind of the observer pattern or data binding or something like that. So observer pattern is when something changes, then tell me about it. Well, I can map that into my signal and event model as well. Target action, same kind of thing. Again, that kind of is done for you in Cocoa, but you end up with, you've got 4 different things, 4, 5, 6 different ways of being notified. And you end up with, depending exactly what your use case is, you end up writing different code for all these different things. So what you can, by using this kind of functional reactive programming model, you can map all of that into one single kind of thing. And then box numbers and closures. Now, a little bit more high level, what kind of stuff can you actually model with it in a more kind of real world example? Asynchronous tasks. So this is a task, I'm going to kick it off, and at some point later I'm going to get a callback. Well, that callback can be an event on my signal. Network events, so then we're going to kick a network event off. You know, it's going to take ages, it's going to come back down with that piece of string, I'm going to get this thing. And then I could have an event saying, here's your payload, or I've got a stream of data, here's the first bit, here's another bit, and I'm just going to keep sending data over. User interaction, and this is often where, so the framework that I'm using to talk about this is called Reactive Code, and this is where everything always starts, is people interacting with your app, your user interface, is a stream of events. So people typing on the keyboard, that's just a stream of events. You know, a new event saying, here you are, this is what they type now, oh, it's just changed, this is what it is now. Tapping buttons, again, a stream of events. Okay, so I hope we've now got some kind of concept of what signals are and what events are, in fact they just flow out of it. But in itself, it's maybe not overly useful. Now, there is some use in the fact that I've now got a unified homogeneous way of dealing with events, but still, that's not really covered what we can do with functional reactive programming. And this is what I'm talking about here is signals work best when you fit a functional pipeline around them. So, what do I mean by that? So we've talked about what functional things are. They're these methods, these functions which take an input and give you an output, and they have no state associated with them. Now I can compose a load of those together that act on the events that I give it. So events come streaming out, they go through my pipeline of functional functions. All functions are functional. And then out at the end of that, then I get something else. So these are the kind of functions that you see that are associated with streams. And I'm sure a lot of you will recognise this kind of thing. So map is each thing that comes through my pipeline, I want to do this to it. I want to take it and I want to create something new based on it. Filter is things are coming through. I'm only interested in ones that obey this particular predicate. Etc. You don't need to go into those in detail. There are loads of them, they're massively powerful, you can do all kinds of different things. I think, really, I need a real-world example, because it's all been a little bit academic so far. So, bear with me, I'm going to try and do a little demo. I'm not going to show you any of the code, I don't think it's particularly relevant. Right, so what I've got here, right. So I've got at the top just a text field, so this is an iOS app to simulate loads. At the top there's a text field, and then down the bottom is it's just a table. And what I've done is set it up so that I've attached something called a text event. A text signal to my text field, and every time it spits out an event, then it'll add it to the table. So if I'm in here and I start typing, then you can see that these are new events coming up. So my text field is spitting out events. Each event is something has happened to the text field. Somebody's done something with the text. And you'll see the interesting part. So I've got here, this is time, and then the other side is kind of the payload. This is the content of my event. And the important part here is, rather than receiving they've just pressed the J key, what we're actually receiving is the entire contents of it. And this all comes back to the kind of the immutability of it. All I'm doing is I'm giving the entire content of it. And as I delete, that's more events because there's stuff going. As I type stuff in, then I get more and more events. So I can see that I've now got some kind of stream that's spitting out events. That's kind of all I really want to demo with that. I want to kind of see, well, what can I use that for? So I've kind of modelled this now. We've now got two of these text fields. They're spitting out events. So kind of username field, and then spitting out the name, and then password, that's the password. Each of these little blobs is a new event. Well, it's actually the payload associated with it. So as I'm typing my name, Sam, then I'll get my first event will be an S, and the next one will be SA, and the next one will be SA. Kind of thing to notice there is that I'm getting the entire content. The other thing is it's pushing it at me. It's not telling me something's happened with the text field, I need to go back and check it. It's giving me the entire content. And then the password there, same thing. So what I'm kind of going to talk about now is, I've got a submit button there, which you can't use, and I don't want to be able to, somebody shouldn't be able to submit until I've got 3 characters in each one. So I've got these 2 streams, and what I'm going to do is build a little functional pipeline around it. So my first thing is I'm going to map it, which is going to cut off. So map is take what you've got and then take this event, do something with it, and then spit out the result. So my map is going to be from the string, which is my content, my payload now, right? I'm going to work out find the length of it and then spit that out instead. So now I've got 1, 2, 3, 4. But I only care about events where there's 3 or more characters, because otherwise I don't want to do anything. So now I've now filtered it, so I can just filter based on it's got to be greater than 2 off the edge of the screen. So now I'm only getting callback, I'm only receiving events at the end of my pipeline when I've got 3 more characters. So what does that look like in kind of code? So this is, I realise Objective-C might be a bit scary, so I've rewritten this in Swift, which looks a little bit like JavaScript, so everybody's happy. So what I've got here is, so this first bit here is a rectangle signal, so that's my signal, that's the thing that's going to spit out these events. And then the first thing I'm going to do is map it, which is what I was doing before. So I'm taking in a string, I'm going to return the length of it, so I'm spitting out a number at the end. And then finally I'm going to filter it, so a filter is just takes a method closure which returns a boolean given the input, so do I keep it or do I throw it away? It's basically the question the filter asks. And now I'm only going to keep it if I've got more than 2 characters. And then this is something, so I'm not going to talk about this very much, but now I've got these 2 text signals. Well, one of the cool things you can do is actually join those together.
No signals.
Right, so I'm going to join those 2 together. And what that means is that's going to create a new signal. So I've got 2 signals, I'm joining them together to create a new signal. And then this particular method will spit out it's a tuple which will have the result of each of them. In fact, when one of them changes, it will give you the last received result on the other one and the new value. So that's all it's doing. And then all I'm doing here, so subscription is saying I'm going to listen to this. Now I've got my pipeline, and I'm going to make a sync on the end of it. This is the stuff I'm going to do with it at the end. All I'm going to do is, well, once I receive a signal, once I receive an event, I'm going to enable the button. Now, this is a very simplified example, and in this case, if you were to backspace and then you had fewer than 3, then it wouldn't disable it. That's perfectly possible to do, but it's not really the point of what I'm trying to show. So a more interesting example, because I don't find that very interesting. It's a bit tedious. It's the first example anybody who ever does reactive cocoa has to do is that, so I thought we should do it. But more interesting example. So I want to connect to a WebSocket, so I built a node thing that will gives you a WebSocket, and it spits out when on my WebSocket it will tell you somebody's just updated Wikipedia. Here's what they've done. So that's what it's doing, streaming out these live edits from Wikipedia. So I've got this. I want to do something with it because to me a WebSocket that's perfect. That is a signal. The socket is a signal, and that the events are there's a new update. This is the kind of stuff that you get out of that. It's just JSON. We've got 3 kind of fields in there. We've got a type, which I've not labelled unspecified, which means edit, if we're worried with that. There's the special things, then there's also new user events and all that kind of stuff. There's also a content field, which is usually the title of the page thing, and then the timestamps when it actually happened. So what I'm going to do is, given that, and given that somehow I've got that as a signal in my app, because I don't want to take you through that, that's a bit kind of down in the guts of iOS and Reactive Cocoa. Given that I have a signal on this, what kind of stuff can I do? I want to build some pipelines to use these kind of cool events. So the first one is I just want to show on my app the names of pages as they get edited. So given that I've got streams which are now turned into dictionaries, I've got these dictionaries going through these maps. Maps going through. So first of all, I want to filter it to get unspecified. Unspecified means page edit. It's not a new user event. It's not a special event. Unspecified means a page edit. I should have called it page edit. So I'm going to throw away anything that isn't labelled as unspecified. And I'm going to map it to extract the content. So I've got this dictionary with type, content, and timestamp. I'm not interested in 2 of those. I only want the content. So throw away most of the dictionary. I just want to extract the string. And then this kind of subscribe concept is I've built my pipeline, and I want to do something with those events that come out at the end of my pipeline. And I want to update the label. So what does that look like in code? So a couple of things. First of all, the messages thing is the signal. So there's a messages property, which is a signal. Then everything down to subscribe next as is the pipeline. It's the functional pipeline. And then the thing at the end is the sync. It's the subscription. It's the what am I going to do? What's the end point of it? So as I said, there are 3 things. First of all, we'll filter. So we've got a filter method. We throw away everything that isn't equal to unspecified. Then out of the end of there, we map it. So we've given a dictionary. I'm going to throw away I only want to extract the content field from my dictionary. So I've now got a string, because that was a string. And then finally, I've not highlighted it. Deliver on is quite cool. Whenever you have to deal with anything that's all ready and you're trying to deal with background cues and all that kind of stuff, then it can be a bit of a pain to be able to marshal it back up to the main thread. We have put it on the main thread because we're doing user UI updates. Then in this particular framework and in many other frameworks, all I just have to tell it I want this delivered on this particular thread, and it'll handle it all for me. Magic. But then so now I've my subscribe, my endpoint is update the label. So this just sets the table. We'll see this working, but I'm not going to keep going back and forth to the demo app. I want to do a couple of other different pipelines and do this. So, given that I've got this stream of events, what rate, how often are people editing Wikipedia? I thought that'd be quite cool. But what's better than knowing what the rate is a graph of what the rate. So let's plot that on a chart. So what I'm going to do now is I've got my events coming in. In order to estimate the rate, all I need to do is see, well, given this length of time, how many edits were there? So what I'm going to do is buffer them up. So I'm going to kick up a timer, and then I'll collect all of the events that happen until that timer fires. Once that timer fires, I'll take that collection of events and I'll push it down the pipeline and then cooking it. So that's buffering it up. And then I'm going to map that. So I've now received, the next step down the pipeline, I've received this collection, tuple of events. I need to know how many there are. So my map is just counting the size of that. Oh, didn't mean to do that. And then subscribe to add it to the chart. That's it. So, buffering. There helpfully is a method to do buffering with time. So I've said every 5 seconds, collect all of this stuff and then pass it down. And then my map is simply, I've been now sent the tuple. I just want to say how many things are there in there, so I count it and divide it by 5, which is the time it's been buffering over. Again, we've got this deliver on, and then finally we subscribe next. I've got this data source stuff, and appending a value is that's just the mechanics of how I'm adding stuff to a chart. Not very interesting. And then finally, I mentioned before that we have new user events as well as all these other bits and pieces. So I'm getting these events through some of type new user. So when a new user arrives, let's draw a line on the chart. So now, similar kind of thing before, let's filter, we only want the new user events, then we'll turn those dictionaries, into a chart annotation, we'll add it to the chart. So, filtering, again, same as we've seen before, we filter for the new user events. From the mapping, I've created some method that will go off and return me an annotation. And then finally down the bottom here, I add that annotation to the chart and then do a bit of housekeeping. So, let's see whether this works. Good luck, everybody. Well, I've seen it before, so I don't need to prove it. So I should just quickly show you the code, just to prove that it is that easy, because this is in my mind one of the key features of this kind of functional reactive programming thing, is all of this code to build these things is all in the same place. It's about 10 lines long. If I were doing this using delegation and listeners and things, I'd have classes that listen to other bits and pieces, I'd have all this stuff going on, I'd have to work out how do I get the data from here to there. This all handles it all for you. So this pipeline here, where are we? That looks exactly the same, that's working out the rate, that's pretty much exactly the same as I showed you. Then we've got the one for update, that's the updating the text label, and then this one down here is doing the other thing, new user annotation. So, in about 30 lines of code, there's a fair amount of power. Now, so we have a network. Does that say? So I should mention that because I wrote it in Swift so that everybody can understand it, first of all, you're probably under NDA with Apple, which I'm sure you're all happy with. And second of all, I'm running this on beta software which likes to crash. All perfect for a talk, I think. Do excuse me. Yes. Mark. Boom, right. So this is where oh great, it works. This here, so this is the label updating here. So as these are the things that are currently being edited on Wikipedia. And down here we've got, this is a log which is looking at the rate, so every 5 seconds a new data point will appear on the chart. And then hopefully, great, somebody signed up for Wikipedia, that's good, because that proves that that works. We get a red line whenever somebody signs up for Wikipedia. This is with pleasure. You can spend hours on this. Cool, right, so in summary, which means that I'm about to go over time, which is good. And I've made 3 slides about the notes program. I've put it cool. I think it's cool. I think once you've worked out what a signal does and how you can subscribe to events and all this kind of stuff, then in actual fact it really does make a lot of sense. It's all concentrating about the data flow throughout the program. All too often we spend hours working out how do I get the data from this class here to this one here, because I don't want a dependency, I shouldn't know about it, all this kind of stuff. With this, it's concentrating on the flow of the data that we're dealing with. Very powerful. This is back to the fact that I've got 10 lines of code that will work out the rate of edits on the computer and put it on the chart. 10 lines of code is not what it would take had I done it in a traditional imperative way. And it's fun. So as I was building this app, it's for a blog post, and as I was building it, I thought, well, I'll just show on. I was doing it for charts, so I'll just work out and plot the rate on the screen. And then I started doing it, I thought, quite cool to see whether people are editing the list of fictional ducks, not functional ducks, fictional ducks. So that took me kind of 3 minutes or something to put down. Oh, how I've got these new user events. Let's try and do those. Really easy to do. So I reckon you should give it a try. If you're like me and you do iOS and you do OS 10, Reactive Cocoa is your friend. It's fairly easy to set up. If any of you are iOS people and want to talk to me, I suspect not many of you are. Reactive Cocoa is based on something from .NET called Reactive Extensions, which, when it says based on, it's pretty much copied. The story behind it, the Reactive Cocoa is actually written by about 3 guys at GitHub, and they were writing GitHub for Mac. They were jealous of the guys writing GitHub for Windows because they had Reactive Extensions. So doing what we all do, obviously, is let's go and write a massive framework that allows me to do that. So that's where it comes from. It's very, very heavily based on that. So .NET, go use Reactive Extensions. And then for those of you who are on the JavaScript then Elm is your friend. That wouldn't be a BizTech talk unless there was a language that compiled down to JavaScript. Elm is the one that does that. It allows you to kind of build these pipelines and things on a web page, and you can kind of do all kinds of stuff with it. That's me. As I said, the code will be on GitHub. If you go to that URL, you won't find me. There's a D on the end. And similarly, my Twitter has an E on the end. But the code will be on there. I'll speak about it if you have any questions. Feel free to ask. Thank you. Does anybody have any questions? Hello.
When you're objects in the pipeline of big networks, you're noticing your shop, you kind of abandon that paradigm after it, and that's how you use your refresh
So the reason for that, so are you suggesting that I could push charts down the pipeline or something?
I'm asking you.
Right. So the reason that redraw method is in there, and that is still part of the pipeline, effectively, that is I'm getting events stuffed down my pipeline, and then this is what I'm going to do to handle it. And that redraw is only there because, to do with the mechanics of the way it works. When you provide new data to it, you have to tell it to redraw. Because of the way that happens, then that redraw is actually kind of functional, but that's kind of beside the point. In theory, you can push anything down that you like. You do end up with a lot more copying of objects around. Because of this immutability, you end up with copying of objects. So I have 3 pipelines, so each pipeline will have its own copy of objects from using references because of the immutability. And consequently, when you kind of memory churn, it's exactly the same kind of reason, because you're just making loads of objects and throwing them away. There's no limit to what you put down there. I don't think it would make sense to put a chart down there, but that's just purely from I can't see how that is itself I can't see something that's spitting out charts as an event.
The signals are intrinsically small, probably.
Usually, yes. Hi.
When you talk about immutability, what if you want to transform the event?
So, what you would normally do is spit out a copy of what it was. Now, you actually can mutate depending on what your framework is, you can mutate stuff as it comes through. So you can transform stuff. So immutability is less strong than it can be. But this is so I'm not an expert in functional reactive programming, and the person who coined the phrase might argue that this isn't functional reactive programming for precisely that reason, that these things that are going through aren't strictly immutable. But that, to an extent, is because you're using it in the real world. If you're using it, if you go and go down in a purest functional way, then you wouldn't be able to mutate it because it would be an immutable thing. You couldn't do anything with it. You would take it and you'd spit out something else that was based on that thing that you received.
But if you think of the input you get to a function, then you would return a different result. So how would that break that?
Sorry?
So if you receive all those events being passed, and they're passed to functions, and you get input, and then it is returning output.
So that part is the stateless part, not the immutability. So the stateless part is saying that I pass something into a function, and then no matter what happens, if I pass that same object, or one that is apparently the same, then I'll get the same answer out. And that's saying that the function itself doesn't maintain persistent state. It can maintain, like the buffer does include some state, but there's no persistent state, which is exactly not what happens with. So for example, in iOS programming, and the same I'm sure is true in UI programming all over the place, then you put methods on your objects, which then depend very heavily on the state of that object. That's one of the advantages of it. Well, those wouldn't be considered functional because they're recalled. You actually have more than one input.
Is it the case that the function might have its own state of the buffer?
Sorry?
You're saying that the function might have its own state of the buffer. The difference with that another side where it's shared state.
Yes, yeah. So I mean, a buffer is if my input then is because of what it's doing, my input is no longer, it's kind of a sequence of events, and if I put that same sequence of events in from fresh, then it would give me the same answer. So it's kind of very localized, small state. It's the key is it's not this shared state that other things have access to. It can't do anything. Only one thing has access to. Which incidentally makes things very testable. So if you like testing, then functional programs are your friend because you can. You never have to create some kind of hideous mock object to try and represent exactly what I think this is going to be doing at this stage. I've just got a function, I throw stuff at it, and it gives me the output, and it will always do that because it can't share state with anything else. Which is good. Yeah.
And do you see FRP and kind of MVC or model view style kind of architectures? Can they mix together at all? Or they kind of can't do one without the other?
To an extent, I think they have to, because I've talked about this then, and I've said, state's a bad thing, but you can't cope without a state. You need some state, and in actual fact, this is fitting into an MVC kind of approach. I have my views are laid out. I've done elsewhere, so I've set my view up. And I have all of the stuff I was doing there was in my controller, my view controller. So that there is spitting stuff out into my view, and you can actually use this kind of paradigm really, really nicely with MVVM because then your bindings, as it were, are done through in a functional reactive way. I'm a little bit sketchy on that, but I know that it is used for MVVM because you can get this kind of binding.
So if you're going to do MVVM, then I guess you have the functional sort of pipeline between model.
Yes, yeah, exactly that. So that's how. So something happens. I've updated my model, which means that update is an event which gets put to my view model, and then that can manipulate it however it wants to, and then it does something with it. Probably stores it as state, but you do that. So you use this kind of process for sending these messages backwards and forwards.
Can the pipelines be transactional?
Ooh. Yes. I don't know. I think that will be down to the framework, and I really don't know for Reactive code whether we can transactional or not. I'm sorry, I just could do that. It's hard. Cool.
So, you say you don't need to create mock objects. Say you want to test the application of create, presumably you need to supply a mock website.
Right, yeah, sorry. I'm being maybe slightly facetious. I mean, yes, you need to create. You could create a mock signal or something, so exactly that. So you'd have, rather than connecting to my web service, then I'd create a mock signal, like a test signal or something that emits the same events that I would expect to see from my web. But what I'm not doing is I'm not having to create a class and set up various bits of state on it, so that then when I run my method, I can get the result I expect to see, which is not really what you should be doing anyway, but that's certainly a possibility, right? I've got this object, I want to call this method on it, but I need to set up all these things beforehand. I don't think you have to do that. It's some way, but you do still create some code.
The WebSocket API, is that part of the Reactive framework? I missed the first one.
Oh, okay. So what I did was create a signal. So I've got a WebSocket library that calls back by delegates. So it says you've received a new error, you've received a new message, you've received or the stream is closed. And then I wrote a tiny bit of code to map that into the world of a signal. So then that messages property on the WebSocket object was something that I'd made that had turned what was a delegate callback into a signal. So it was doing exactly the same thing, only rather than handling 3 delegate methods, I have one single place and it spits out various different types of events.
If an exception occurs within one of the functions of the pipeline, does that just propagate down as a signal? Or?
It would propagate as an error, I think. So because they have this state, so then at every stage an event can either be this is the next thing in the stream, the stream's finished, or an error, and then the pipeline can cope with those. So what I've got at the end is subscribe next. Actually, I could tag onto that subscribe error or subscribe completed, and then they would be things that I would do in those situations. So I'm pretty certain that you might have to do a little bit of, depending on what your function is doing, you might have to do a bit of wrapping to say, actually I'm turning this into an error. But yeah, you can do that. And in fact, that I meant to say at the time, this next completed an error, if you've used futures or promises, it's exactly the same. And the promise future is one value, so you don't need the completed, and next is value, then promise is exactly the same as a stream. Only rather than having one event, a promise, we're only got the stream. Pretty much the same concept, but including the temporal dimension. Cool. Yeah, any more questions? Think that.